Hi, everybody. My name is Scott Mansfield. I'm a senior software engineer on the EVCache team at Netflix. So first question is probably, what is EVCache? It is our distributed, sharded, replicated memcached. It has tunable replication both within an AWS region and globally. Oh, I should state that Netflix is pretty much all on AWS, so I'm going to be using those terms. Has a very high resilience to failure because we see it all the time. A recent talk by another employee of Netflix called AWS Chaos Monkey as a Service, which is about right. It's also network topology aware, so operations use closer boxes in order to speed up traffic. There's a bunch of other things in it too that I can't talk about right now. So this is an output from our request tracing system. If you look on the right side, the far right side, there's maybe half a dozen of those that are not an EVCache box. So this is just like a home page request. When you see the home page, this is what comes out. OK, so we'll talk about 3 different use cases, and then I'll talk about the part that's actually relevant, the Go part. So this is a pretty standard look-aside cache. You first ask the cache itself for the data. You go back to the service that actually owns that data. It'll do whatever it needs to do, hit the database. That'll write back into the cache, and then you return the data to the client. And from then on, you actually have the fast cache access. This is the most interesting one, actually. So we have these very large-scale precomputes. The algorithms that create your home page take many seconds to run, so we can't do it while you're waiting. We have to precompute them overnight. And this is terabytes of output overnight. And what they do is they actually just dump their output into EVCache. And because of that resilience to failure, they can rely on it to store all of that personalization output. That includes basically the home page that you see. There's also a pretty standard session storage use case that we have there. So think when you're watching, there's bookmarks every minute. We're pinging and saying, hey, we're here, we're here. You don't lose your place. OK. So our current server looks a lot like this. There's the big old memcached. There's a Prana sidecar, which is our hook into the rest of the Netflix ecosystem because we don't touch memcached. So this is fine. It has been fine for a while. Last year, I don't know, the second half of the year, we transitioned to an N+1 architecture. So we have 3 regions, and we have all data available everywhere because we can serve any member from any region. And that actually got a lot more expensive because everything's sitting in RAM, and RAM is expensive. And also, at the beginning of this year, we launched in 130 new countries, so that's a whole lot more that we're actually pre-computing every day and putting into the cache. So to help reduce these costs, we actually changed our server a lot. Oh, I should note also our access patterns are very heavily region-oriented. So if you're in Europe, you're probably not going to be hitting the US data centers. So what we did is we changed our server, introduced a couple new processes on there. We have Rend, which is memcached proxy, and Mnemonic, which is our SSD-backed solution. So here we have a memcached still, which is like our L1 cache, and then we have an L2 on SSD. So this still looks like memcached. It's wire compatible. Our client library didn't have to change at all. So Rend is the part that I worked on primarily. It's a high-performance memcached proxy and server, so it's a set of libraries, and it's actually reused in Mnemonic. It's written in Go because Go is awesome, and mostly because I can just use a single Go routine per connection. It's a very easy pattern, and it makes things very clean. It manages the L1 and L2 relationship on the box. And for us, a requirement from the very beginning was to handle tens of thousands of concurrent connections because some of our caches have a lot of traffic and a lot of connections. So Go is kind of a natural choice here. Mnemonic reuses a lot of those same code, but it has a C++ library that's wrapping RocksDB to actually do the storage on disk. And that uses CGO between there. OK. So in production, we actually run it more like this. Rend is running with like a standard port where you'd think like the normal read, write, back and forth. And then we also have what we call batch port. So those large-scale precomputes that I talked about, what we're doing is writing directly into L2 and then replacing any hot data that's actually being used at the time. So this is already serving some of our really important personalization data from those precomputes. And so if you're visiting Netflix at any time in the past couple weeks, you've been hitting some Go code in the caching layer. Right. OK. Naturally, we have some parts of this open source. So our client is just under EVCache, and then Rend is the proxy, and some of that code's reused. The mnemonic part isn't open source yet, but should be soon. Okay. I don't have anything else. I think I was a little bit faster than I intended, so we have a little bit more time for questions, if anybody has any.